Okay, today we're talking about projectile motion. If I were standing up here about 8 feet off the ground and I launch a ball up in the air and then it comes back down again, can you picture that sort of looks like a parabola? That's like x squared, blah, blah, blah. In fact, it's an upside down parabola, so it has to be like negative x squared, blah, blah, blah. All right, so let's look at negative x squared plus 4x plus 4. Put that into your calculator, hit graph. Negative x squared plus 4x plus 4. And it looks like this. Now, there's several important points on here that we're going to be asking you about. Today is kind of a review day. We did this before. And you're going to be pretty good at the calculator by the end, I hope. That spot right there, called the Y-Intercept, also known as where x equals 0. You can find that Y-Intercept fairly easily. Just by looking at the graph, you can see it. It's not hard to locate. Okay, but where do I find it in the actual equation? Well, the Y-intercept is where x is 0. So if I go back here and I imagine that I put in x is 0 in my head, do you get that the answer must be 4? So I don't need to look it up on the graph. I can look it up on the equation. The Y-intercept is 4. Now, why is that important? Because the question in the real world might be, looking at this graph, what is the initial height of the object before it was launched? That would be at time 0. That'd be this spot. That'd be the Y-intercept. There's another important spot, and that's the highest that it ever gets right there. That's called the maximum. I'm going to do that with you right now. Grab your graphing calculator and get the graph on your screen like this, and then go to second, calculate, maximum. Now, this is, did you find that? It gets, so a second, calculate, calculates right above the trace button. I'll do it again more slowly. Second, calculate, I'll leave it on the calculate button. Need one of these?
Yeah, my calculator's turned on.
All right, here you go. Take either one of those. And now maximum is the fourth one down. Hit the 4. How many of you remember doing this before? Raise your hand if you remember finding a maximum. All right, there's a few of you that are good at this. Some of you aren't. All right, I will go slow then. You ready? You have a calculator? You all need a calculator. Okay, I just couldn't see it. All right, good. So take your calculator, get to the part where it says second calculate maximum, and it says left bound. You want to be just to the left of the top. Now, think before you do anything here. Do you get that the x here is right around 1? That's where I am. I'm at where x is right around 1. I have two choices. I could either hit enter, which is probably the easiest choice, but I think some of you are going to actually like this better. You can choose what your left boundary is by using your head and thinking, oh, I want it to be to the left of the top spot there. That'd be about 1. You hit the 1. See how it pops up an x equals 1 on the lower left? Enter. And then what would be just to the right of it? Maybe x is like, I don't know, 4, 3, something like that. I'm going to say 4. I could arrow, 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 5, 6, 7, 8, 9, 10 hits and be to the right of it. Or I could have just thought, well, that's going to be around x equals 3. So I could hit a 3. Enter. Now I've picked to the left and I've picked to the right of it. Now it says guess. Guess is always saying move your little cursor thing until it gets to the spot where it's at the peak. You're really close to the peak, and then hit enter. I want you all to leave this on your calculator while I hit pause for a second and walk around the room and make sure people know what they are doing. If you are already here, awesome. What you could do is find your assignment and open it. I don't want you to start it, but you could find your assignment and open it while I'm helping everybody get to the right spot here. The assignment looks kind of like that. All right, I'm going to pause for a second. Here we go. All right, got those calculator issues fixed. So now, when you have a graph that's like this, there's 4 important spots on it. Number 1 is the Y-intercept. You don't find that on the graph. You find it in the equation. All right, next thing, this top spot, we just did that. That's called the maximum. That's made up of 2 numbers. In our problem, it came out to 2, 8. That is an x and a y. Is that like 2 chickens at 8 seconds? No. What are the 2 things? Okay, need you to focus on this now. We'll deal with calculator stuff later, because you got to get this part next. Shut the iPad. Thank you. All right. So tell me, what's the 2? Excellent guess, except they're reversed, so try it again. After 2 seconds, this is time. The X number is time. The other number is the feet in the air. X is always time. X is always time. If time is on your graph, you're going to put it on X. That's really, really rarely ever changed. You could probably find some weird instance in a physics class or something where you want to put time on the y-axis, but I can't think of one. So X is time. The Y is always, in our case, going to be height. So if I hit this spot and I say it's 2, 8, you have to know which part of that is the answer. Well, it depends on what the question is. The question is, when did it hit its height? What would you say? 2 seconds. If the question was, how high was it at its maximum? You'd say 8 feet or 8 yards or whatever. Okay. So this has always got 2 parts, and you got to know which one's which. All right. The next one is, what if I say, where is it after 3 seconds? You don't know how to do that yet. Let's get your graph up again. Oh, you do? Good. Tell me. I've got my graph up. What do I do? Okay, you're doing some. How about this? Tell me what buttons to push to get that answer. Oh, okay. Second, calculate, and it's one of those. Which one do you think it is? It'll tell me how high it is after 3 seconds. Value, you are correct. Second, calculate the value. It's the number 1 thing there. And now, see how it pops up X equals and it's got a blinky? It's saying, what does X equal to? And I just told you it was going to be, time was going to be 3 seconds. So put in X equals 3. And I hit enter. And it'll tell me where it is. See, it even puts the little spider thing on there and it says that's where it is at 3 seconds. How high is it? 7. So it's 7 feet off the ground, or 7 miles off the ground if you're talking in terms of like a spaceship or whatever. So at time 3 seconds, it's 7 off the ground. I'd like you to try that yourself without my helping you. Where is it at 4 seconds? Use your calculator. Remember, that was second calculate. Yes, sir. Oh, could you go and find this in the table? Absolutely. But I think I'm trying to show you everything on the second calculate menu today. Go on. Okay, good. So second calculate, I want to find the value. X equals 4 seconds. And you said it was what? 4? Look at that. 4, 4. Okay. There's one last kind. There's this spot right here. That spot right there might read something like this. You tell me. Would it be something like 8, 0, or would it be more like 0, 8? Is it more like 8, 0 or 0, 8? 8, 0. Okay, and then think about this. If X is time and Y is height, this is the time and this is the height. Does it make sense that the height would be 0? Yeah, it's hit the ground. So this is not where the thing hit the ground, it's when the thing hit the ground. Use our graph and find it. I'll show you how. Go back to your graph. It's this spot right about there. Could I just like move my little cursor down on top of it? Yeah, but that's not the best way to do it. Let me show you exactly where it hit the ground. Not where, when it hit the ground. Go to second, calculate. And does anybody know what that spot is called? It's one of the 0. Very good. Yes, it's kind of an intersect, but we've only graphed one line. Those axes that are in there, those aren't lines that are graphed. Okay, so we only had one line. We can't have an intersect. So we have to do the 0. Second, calculate 0. Now this one's a little weirder because you have to get to the left of the 0. Here's my 0 point right there. That's the spot we're talking about. How do I get to the left of that? I already am to the left of it. But wait, you say. But you're above it. You're not to the left of it. Aren't I above it and to the left of it right now? So it's asking for the left boundary. I hit enter. And I don't know if you can see this, but it pops up a little triangle on your screen and says, oh, so that's the left boundary. Now you arrow over to the right of your important spot. Now, yes, I'm underneath it, but I'm also to the right of it. and I hit enter. And now guess, that means get really close to where you think it is. And it's about there, close enough, hit enter. Don't get too paranoid on guess, because it's just going to pop to the exact right spot anyway. 3 things again. Get to the left of it, get to the right of it, get on it. Hit enter. Now the only thing that's confusing about this to me is we just said a second ago, this is supposed to be where the height is 0. And how come mine says that weird thing? It's because the calculator cannot get exactly to 0 sometimes. Why? Because it's actually reading its own picture. It's not doing it mathematically like you would think it is. It's actually reading its own picture, and it can't get perfectly to 0 sometimes. Would you agree that -1 point with a decimal point moved 12 spots to the left of it? That's really close to 0, isn't it? So when it says something like that, it means 0. So that's the 0. And it was at 4.82 seconds. So moral of the story, how long was this ball in the air? Well, until it hit the ground, right? From 0 to 4.82 seconds. So it was in the air for 4.82 seconds. I could ask you, what's the highest it ever went? And then you do second calculate maximum. I could do, where was the ball at time 1 second? Do that one for me one more time. Where was it at time 1 second? Second calculate. At a value of time equaling 1 second. Give you a hint there. It's second calculate value. And the time x is 1 second. And did you get 7? Raise your hand if you had it right. Okay, good. I think you get it. You know everything you need to know. And now we still have about a half an hour left for you to work on your homework. I am going to make it just a little easier because I think there's 4 problems at the beginning that are a little bit elementary. I'm going to let you skip problem 1 and problem 4. So let's start with problem 2. Okay, so everybody get to your worksheet, find problem 2. I will do it with you. Make sure you're understanding it. Okay. It says round all answers to 2 decimal places in the directions, just in case you don't notice that, because there are going to be a lot of decimals on this. Don't let that freak you out. That needs to go away and never come out again. Thank you. All right, number 2 is x squared minus 4x plus 1. So I'm going to put that in here. Ooh, I was really close to that, but I just need to delete this negative, make that a minus 4x, and then plus 1. Don't use a negative, use a minus. Plus 1. Graph. All right, this one is right side up parabola. What are its x-intercepts? Those are also called the roots and also called the zeros, remember? So we're going to do second calculate zeros. Second, calculate the zeros. And I got to get to the left of it. I already am. Cool. Now I'm going to get to the right of it. And I hit enter. And now I'm getting right on top of it. And I hit enter. Close enough. It'll jump to it. There it is. Now for those of you that are advanced users, after you write down this 0, which is 0.2. Now how many decimal places? 2. Okay. So 0.27. And if it's an x-intercept, put comma 0. What I'm saying? 0.27 is not a good answer. 0.27 comma 0. That's an x-intercept. In the context of a graph, that's what we should do. 0.27 comma 0. And the other one, oh, I can get that by, I'm going to do it in a more advanced way. If you want to be a more advanced user, watch this way. Second, calculate the 0. Now I'm going to say, I know I need to be to the left of that other spot, and I can see that that's about 3. I just hit 3 to answer its question of what should the left boundary be. Did you get what I just did there? I didn't have to arrow over. All right, now I'm going to say, I know if I go to like 5, it's going to be past it, so I'll say my right boundary is going to be 5. And now I'm going to say, guess. I'm not going to guess. I'm just going to hit enter, because I know I'm close enough, and it'll just jump right to the answer. So that's just a little faster way to do it. You can type in You know a number that's to the left of it. You know a number that's to the right of it. And now it jumps right to it. And the final answer then is 3.73, comma 0. 3.73. Yep, super fat writing. And not in a good way fat. 3.73, comma 0. There we go. Okay, the vertex. Ooh, this isn't the maximum this time. It's a minimum. I'm going to use the more advanced way. Second, calculate the minimum. I got to do all of this the normal way. Left boundary, to the left of the minimum, I know 0 would be to the left of the minimum. Get where I'm going here? To the right of the minimum, I know that 4 would be to the right of the minimum. And now guess? I'm not going to guess. It'll jump there for me. Boom. 1.9999999, do you know it probably means 2? I do. 2 comma negative 3. There's my vertex. 2 comma negative 3. I was wondering whether I should teach you the more advanced way or not. How many of you are actually using the more advanced way? There's 4 or 5 of you. All right, good. You don't have to. You can just arrow around, and that's fine. Okay. We're done with problem 2. Remember, I also said you could also skip number 4. So we're done with 1. You never had to do it. 4, you can skip. Do problem 3, and then you're on to some word questions. Don't let them scare you just because they have words. One thing they're going to ask you about is to find the window. What does that mean? Well, when you have, see, everybody look at number 5, please. The window question, once you've graphed this thing and you've made it so you can see it, you're going to make a sketch of it. By a sketch, this is a sketch. That's okay. I don't expect it to be beautiful. It's not a graph. It's different. It's a sketch. It's a quick sketch. Then these window settings, they are just hit the window button and tell me what it says. So like for my last question, the window, I just hit the window button, and its x min is negative 10. See, it says that, top line there. X min is negative 10, x max is 10. So I'd say negative 10 to 10. My y min is negative 10, my y max is 10. Negative 10 to 10. It's not always going to be that. What if you zoomed out? That would change your window. So just hit the window button, write down what you see. You never have to write the scales. It's just count what it counts by. The x scale and the y scale, we always count by 1s, so that's kind of irrelevant. All right. I think I've taught you everything you possibly need to know. If you get stuck, I'm going to be walking around asking if you need help. Please ask me. And that's all I have for the recording for today.